Very exciting.
Write down the word prisms. We just have a little short yet exciting discussion about prisms. A very short yet exciting discussion about prisms. The exact definition of a prism, children, is, right out of the book, a three-dimensional solid with two congruent bases. A 3D shape that has two congruent, which means exactly the same, bases. Now, in order for you kind of to catch on to this, you must understand what is a base. What is the base of a shape? Okay, and here is my, for example, for instance here, we'll get to, okay, this little shape right here, if I asked you what is the shape of the base, you know, if I'm sitting like this, okay, the shape of the base actually is a hexagon, but why isn't it this rectangle? Why is that not a base? Because I can set it like this, sitting like that. Why is the hexagon the base?
Because there's only two hexagons already, and there can only be two bases.
Sure, that probably makes sense, but I don't know. What I would like you to think about with bases is this. I like to call it my loaf of bread theory.
That's perfect. I'm hungry.
And the gist of that is this. If you're looking for what shape the base of an object, of a three-dimensional object is, think about a loaf of bread, and if you are slicing that loaf and wanting to put it in a toaster, which way would you slice it so that you always get an identical piece? Or if you're making a peanut butter and jelly sandwich, which way would you slice it? And obviously with this you talked about it, it already is the hexagon there. If you sliced it like this and kept doing it like that, you'd end up with pieces of bread. One would be a rectangle this size, and then the next one would get a little bigger till you got to the middle, and then it would get smaller again. But if this was the loaf of bread, you keep slicing it. If you actually were talking about a loaf of bread, you know, that looks a little like this. Now, what would be the shape of the base of that loaf of bread? It's that shape that you always see. It's this. This is the base of that shape. And that's the same with any three-dimensional shape. When you talk about prisms, the base of it has to be where you slice it there. Now, there are some special cases to that, and this would be one of them. This is a rectangular prism. Okay, what shape is the base here? Well, technically, this you could make anything the base. Because if it was a loaf of bread, you could slice it like this and always keep getting those squares. You could cut it like this and always keep getting these rectangles. You know, rectangular prisms are special in that any side you could call its base, because technically, you know, even using Wade's theory that, you know, the base had to be two identical sides, this does, every one of these has its little partner there. Now, with that being said, we always name prisms, they are named by their bases. Okay, so you saw that one there, you know, the one we had here, which is a hexagon. Since the hexagon is the base, we call that a hexagonal prism. A hexagonal prism. Okay, if I asked you to draw a pentagonal prism, okay, you are going to start with a pentagon, which is a five-sided shape. 1, 2, 3, 4, 5. And you would draw that same exact pentagon up here, if you could. That's in your drawing capabilities. And then you could just connect the corners. a dashed line, that would be a dashed line. These would be dashed back here because you can see them. And if you were any good at shading, you could always kind of shade in a couple just to get some to the sides there. Kind of gives you the three-dimensional shape of that thing. That is a pentagonal prism because the base is a pentagon on the top. Now, with that being said, you also need describe a couple things, and I think we've probably talked about this. What are vertices?
Yep.
And what are edges? Edges are the same thing as corners or points. And edges are corners. Vertices are the points where things come together. So if you're looking at vertices of our hexagonal prism, how many vertices it has? Actually vertex, I guess. Vertex. 6 right there, and it would also have 6 back here on the other side that you really can't see. So how many total vertices would that have? 12 vertices. How many edges? And edges are the corners. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 edges. Okay, every straight line that you really draw to draw that shape is going to be an edge. So like this guy here, you've got 5 to make the front pentagon, 5 to make the back pentagon, and then 5 that you draw to connect those. So there's going to be 15 edges on there. 15 edges and only 10 vertices there. An octagonal prism. You'll start with your octagon. Let's make it a short squatty one here. Just come off of this about that same size. You ain't gonna see this one too much here. What happens here? This goes off there, this goes off here. And this gets connected there. Sure, why not? There, this goes off here, gets connected there. And you can't tell why because we need to make some dashed lines. And you still can't tell because we need to do some shading. This will make it look a lot better.
Okay.
And these sides. I should have made this a little dashed right there. And this one should have been right there. If I asked you how many edges does an octagonal prism have, how many edges would that be, Bryce? 8 to make the front.
16.
No, 8 to make the back. And then you've got
24.
24.
24.
24.
Oh, yeah. I have a stupid theory.
And then how many vertices? 8 right corners
16.
right there, and 8 corners to make the back.
14. 16. Yes. 8 plus 8 is what? 47.
I think it equals 4. 8 plus 8 is 17.